Non-statistical methods in AIML. Neural networks. Definition: computing systems inspired by the biological neural networks that constitute animal brains. Examples: feed-forward neural networks (FNN), basic type of neural network where connections do not form cycles. Convolutional neural networks (CNN), specialized neural network for processing data with grid-like topology, such as images. Recurrent neural networks (RNN), neural network where connections form directed cycles. Suitable for sequence data. Long short-term memory (LSTM), a type of RNN that can learn long-term dependencies. Generative adversarial networks (GAN), neural networks consisting of two networks, a generator and a discriminator, that compete against each other. Evolutionary algorithms. Definition: optimization algorithms inspired by the process of natural selection. Examples: genetic algorithms use techniques such as mutation, crossover, and selection to evolve solutions to problems. Differential evolution uses vector differences for perturbation of individuals. Particle swarm optimization optimizes a problem by iteratively improving candidate solutions with regard to a given measure of quality. Ensemble methods. Definition: techniques that create multiple models and then combine them to produce improved results. Examples: bagging reduces variance by averaging the predictions over several models trained with different subsets of the data. Boosting reduces bias by sequentially training models, each correcting the errors of its predecessor. Stacking combines multiple models by training a meta-model to output predictions based on the predictions of the base models. Rule-based systems. Definition: systems that apply human-defined rules to process data and make decisions. Examples: expert systems use a set of rules provided by human experts to make decisions. Production systems consist of a set of rules and an inference engine that applies these rules to a working memory. Reinforcement learning. Definition: learning paradigm where an agent learns to make decisions by taking actions in an environment to maximize cumulative reward. Examples: Q-learning model, free reinforcement learning algorithm that seeks to learn the value of an action in a particular state. Deep Q networks (DQN) uses deep learning to approximate the Q values in Q-learning. Policy gradient methods optimize the policy directly by gradient ascent on expected reward. Heuristic methods. Definition: techniques designed for solving problems faster when classic methods are too slow or fail to find any exact solution. Examples: a star search algorithm that finds the shortest path from a start node to a goal node using heuristics. Simulated annealing, probabilistic technique for approximating the global optimum of a given function. Taboo search, iterative search algorithm that uses memory structures to avoid cycles and improve performance. Graph algorithms. Definition: algorithms for solving problems related to graph theory. Examples: Dijkstra's algorithm finds the shortest path between nodes in a graph. Bellman-Ford algorithm computes shortest paths from a single source vertex to all of the other vertices in a weighted digraph. PageRank algorithm used by Google Search to rank web pages in their search engine results. Natural language processing (NLP). Definition: techniques for processing and analyzing natural language data. Examples: tokenization, splitting text into individual words or phrases. Stemming, reducing words to their base or root form. Named entity recognition (NER), identifying and classifying key information entities in text. Machine translation, translating text from one language to another. Sentiment analysis, determining the sentiment expressed in a piece of text. Fuzzy logic. Definition form of many-valued logic that deals with approximate, rather than fixed and exact reasoning. Examples. Fuzzy inference systems map inputs to outputs using fuzzy logic. Fuzzy means clustering technique where each data point belongs to a cluster to a certain degree specified by a membership grade. Case-based reasoning. Definition problem-solving paradigm that uses the solutions of past problems to solve new problems. Examples. Retrieve finding cases from the past that are similar to the current problem. Reuse adapting the solutions from retrieved cases to the current problem. Revise correcting errors in the proposed solution. Retain storing the new solution as part of a new case. Constraint satisfaction problems. Definition problems that require a solution to satisfy a number of constraints. Examples. Backtracking systematically searches for a solution by trying different possibilities. ARC consistency ensures that every value in the domain of a variable satisfies the variables. Binary constraints. Local search moves from solution to solution in the space of candidate solutions by applying local changes.